Hello, this is our CS536 final project. Our project is on ChatGPT-on-Phone, and I'm Zhao Peng.
He is Xingpeng.
He is Hao Meng.
With the success of ChatGPT in various platforms, there is a significant opportunity to bring its capabilities to mobile devices in an interactive and user-friendly manner. With advanced speech-to-text and text-to-speech technologies, we develop a mobile chatbot that works with ChatGPT. The app uses human speech as the input and the output, allowing users to interact with the chatbot using voice commands and receive audio responses, enhancing user experience and accessibility. To build the client, we use Swift to develop the app, which could be directly deployed on iOS. Here is an overview of our system design. First, the user will input the voice to the mobile client. The client will use speech-to-text technology to process the voice input into text. Then the mobile client will send the text to OpenAI server through API call. After receiving the response from the OpenAI server, the mobile client will process the text into voice through text-to-speech technology and give the user voice feedback. Now I will introduce our UI. To build the UI of our mobile client, we use Swift in Xcode 15. We built several simulators over different environments, including iPhone, MacBook, and iPad, which all could be used as the mobile client of our product. On the right is a figure for our UI on an iOS simulator. It follows the general workflow of chat apps. On the bottom, there is a voice input button which enables the user to directly input voice. Since the user may make mistakes when inputting the voice, we will show the speech-to-text stream response to the user and enable the user to modify the input before sending the request through the send button. For the speech-to-text technologies, we try different designs. OpenAI provides an API called Whisper. The API will provide a trained model which will return more accurate responses. It could understand the context and automatically filter out noises. Another choice is to use the iOS built-in function, SF Speech Recognizer. It could provide real-time stream response, and there will be no latency, which might be caused by the network issue. Since we don't want our user to wait for a long time for the translation, we decide to adopt Design 2. In our field tests, we also verify that this built-in function would not have too noisy text. The quality of the output could be used for the following pipeline.
In our system for the GPT model, we specifically picked GPT-4 1106 preview model because it is the most state-of-the-art model and can give us the response quickly and accurately. So in our GPT design, we insert a system prompt so that to ask the GPT chatbot to pretend as a computer network assistant, and therefore it can help us to solve and answer computer network related questions. So this is also like a improvement and a design in our pipeline. And below it, this is a Swift code snips that shows how we connect to the OpenAI GPT APIs. So in our design for the text-to-speech feature, we use the iOS built-in AV speech synthesized voice, which is an iOS specific package. So in our test, we find out this package cannot be compiled with iOS 17, so that we deploy it on iOS 16 and test it on the iOS 16 iPhone to do the field test, and it works smoothly. This package can give us real-time text streams or complete smooth voice broadcasting, and we will compare those two different kind of designs in our following pipelines. So we have designed our network algorithms that can do the real-time stream response, and we compared it with the complete response, which means that once we send a message to the ChatGPT, we can do two things. First one is to have the GPT to give the response, and we streamly output the response in the text box, or we wait to the GPT to give us the whole bunch of message, and we upload the complete message into the text box. So in our design, we do the stream response using the OpenAI API, and it basically use the WebSocket algorithm, that is a communicate protocol that provide a full duplex communication channel over a single long-standing TCP connections. And this is a continuous connection allowing for two-way communication. So WebSocket, unlike traditional HTTP requests that are initiated by client and responded to by the server in a stateless one-off manner, it maintains like continuous connections. And specifically, in the context of OpenAI stream response, the server, which is the OpenAI model server, continuously send response or update to the client, which is our iOS app, as they are generated. The client, which is our application, receive those updates in real time and enable dynamic and interactive experience in the live chat box conversation and the real-time streaming. So once the WebSocket connection is established, both the client and server can send data at any time. The data is typically framed in the WebSocket specific format and can be either text or binary data. So below it is our code snippet that shows how we write the stream live message using the algorithm we designed. So our algorithm has some trade-off. So for the stream live response, we can give real-time feedbacks, but the text-to-speech voice is pretty stiff. And if we do the complete message response, so the voice can be more smooth and the broadcast be more smooth, but we need to wait for a while to let the OpenAI GPT to give us the response and then do the text-to-speech feature. And we will show our different pipelines in the following demos to compare their advantage and to also show the demo that works on the real iPhone, the real iPhone iOS 16s.
Okay, we would have 5 demos in total, so the 5th one will be our complete version. In this demo 1, this was our first prototype. In this version, we didn't have any voice to text or text to voice. We mainly focus on how network transmission works, and you can see that the response will be very slow because we use the API and it will wait until everything is complete, then transfer back to us. So the first response was fairly short, so you don't experience much delay, but the second one, if the response will be longer, you will experience much longer delay. And yes, so it takes that much time to generate those texts and then send back. And for demo 2, for demo 2, we implement a stream response, which means the response of this OpenAI API will be sent back to us word by word. In this case, the user experience will be more smooth. So if we ask the same question, in this case, what is TCP? Yes, it will generate the response word by word and send back to us instantly. For the next one, we implement some text response with voice to text and text to voice.
Hello, how can capital I assist you with understanding how computer networks work today?
What is TCP?
TCP stands for Transmission Control Protocol. It is one of the main protocols in.
So this stream text text to voice pipeline will transfer the word instantly as soon as the word sent back to us from OpenAI. So we think it will be better, but in real world it's not smooth. So we decide to go to the final approach, which is just wait until everything is complete
Hello?
and then transfer it to voice.
Hello, how can I help you understand how computer networks work today?
What is TCP?
In this case, user can still see as soon as possible the answer is generating, and then after the answer is done, it will convert this into a better, smoother voice.
TCP stands for Transmission Control Protocol. It is a fundamental protocol in the suite of Internet protocols that are used to manage data transfer across network and computers.
And lastly, we just deploy this into our iPhone 12.
Hello?
Hello, if you have any questions about computer networks or how they work, feel free to ask and I'll do my best to explain in simple terms.
What is TCP?
Sorry, we go over these questions 5 times. In this case, we'll have a better experience in between how we improved our app time by time.
TCP stands for Transmission Control Protocol. It is like a set of rules that helps computers on a network share information with each other in a reliable way. Imagine you want to send a letter to a friend, but the letter is too long.
And yes. So comes to the conclusion, we have successfully built a voice chatbot, and we implemented real-time feedback on text with a smooth broadcast, and we came up with a simple but intuitive user interface, and we also put a lot of effort on how to actually deploy this app in our iPhone. And overall, we accomplished what we have promised, and we indeed learned a lot about networks and how to conduct a better app based on these networks techniques. Thank you.